So hope you had some eventful lunch downstairs with the food stalls put up by our food science and food and nutrition department. We are back for the afternoon session, and in this session we have a very interesting talk which is on current day topic AI. So I invite Dr. Veeresh, Head of Computer Science Department, to introduce our speaker.
Good afternoon all. It's my privilege to introduce Professor Sudha Madam. Thank you for giving me the opportunity to the organizers. So, Professor Sudha Madam is a distinguished academician and administrator with extensive experience in higher education and academic governance and leadership, research leadership. Madam holds her PhD in computer science and engineering from Jawaharlal Nehru Technological University, Hyderabad. Madam has served in several key leadership roles, including former head Department of Computer Science and Engineering, Director of the ERP Cell at University College of Engineering, and in charge of the Cloud Computing Research Laboratory, Usman University. So, Madam is one of the research areas cloud computing. So on the cloud computing, Madam is going to deliver a lecture. Madam has also contributed significantly to the institutional development as an executive coordinator and as a member of various academic audit and advisory committee at university and inter-university level. Madam's research interests includes cloud computing, machine learning, data science, and distributed systems. So, Madam, we are fortunate to have you here, Madam. So, kindly continue the session.
Very good afternoon to one and all. Now I have been given the toughest part of the job to keep you awake after the lunch. So it's great to see all young women keen to hear, keen to learn something, especially on this National Science Day. Yeah, except I think a few who are very busy with the phones. They are so busy that they can't even hear that I am talking about them. Before I get into the topic, I just what's the right one? So before I get into the topic, this is a brief statement. Right? How are science and engineering related? What is science and why and how that is different from engineering? Science forms the basis for engineering, or engineering forms the basis for science? Would somebody volunteer to answer? Yeah, girls say?
Science forms engineering.
Science?
Science forms engineering.
Yeah. So if I want to talk about engineering also, unless I know that scientific approach, right? Unless I have that scientific way of thinking, I can't be doing it. And more so if I am talking about AI, if I am talking of smart cities, if I am talking of cloud computing, nothing is possible without having a scientific bent of mind. So with that, I think we get into slightly, I don't know if you can catch up, but you can interrupt me if you can't. So today with the interest that has grown in AI, what you must have heard of the recent India Summit, India AI Summit at New Delhi, that went on for 3 full days, and on the stage you had people from all the top companies, CEOs of top companies, with presidents and such great people like our Prime Minister and so many such people. Why are they bothered? Why should they be bothered? If it is AI and if it is something related to this specific branch and specific application, why should the leaders be bothered? So we saw that, or they also understood, the entire administration, the leaders, they all understand that this AI is something that is going to transform. How it is going to transform? It is going to transform the way not only administration or governance is going to be done, but also how various cities are going to look like in the future. That brings in this idea of smart cities. Now, if we want to talk about smart cities, the foundational idea is that there is something called as computer vision. Today, all the data that is getting captured, okay, the basis for all of this data being used is something called as computer vision. So, this is the foundational technology for all kinds of smart cities. These smart cities, which enable automated perception, monitoring, and decision making from all your visual streams. So whether it is your CCTVs or your cameras and signal-based cameras, from all of that, the data that is getting captured in the form of images, that is what is being used for doing a lot more. What is it that is being done? What actually, before we get into the details of all that, what we can do is we can see as to what really contributes to a smart city. What happens in a smart city? There is something called as intelligent traffic management that can be done in a smart city. Intelligent traffic management, because what we see is there is a need for vehicle detection, counting, classification. Those who drive must be knowing that you get as soon as you try to break the rules. There is a red signal and you try to break the rule. What happens? You get a penalty. You get a memo. You get a something that you need to pay. You need to pay 2,000 rupees. It is a car. For two-wheelers, how much is it? 500. Right? So if you break the rules, earlier you had a policeman or somebody taking up that data and arguing or discussing whether it should be 500 or 200. Right? And then there are always this idea that they are maybe corrupt and maybe they are pocketing it and so on. But today with computer vision, what happens is there is intelligent traffic management. There are cases. So there is this idea of vehicle detection, counting, classification. There is so much more that is called as downstream task. Once you are able to identify the vehicles, once you are able to classify, there is a lot more that can be done. Right? You can see which type of vehicles are violating the rules, which particular age group of people are violating the rules, and so many such kind of statistical analysis can be done, and suitably the cities can be planned. So similarly, there could be something like adaptive traffic signal control on real-time handling. Earlier, we had this idea that at a traffic signal, it was already pre-timed. Pre-timed, 180 seconds or 60 seconds and so on. But that is not useful. In the afternoon, at the same signal point, if you see, you will probably be less traffic density. So unnecessarily waiting for 180 seconds is wasting everybody's petrol. Indirectly, that's a national wastage, which is not recommended. So probably real-time sensing of the traffic density and changing the signal timer, right? Adaptive signal timer modification. That is also possible when data is getting captured from multiple locations and then there is some kind of aggregation being done on that data. Actually, you could take up this kind of a problem as a project, as your summer project. Obviously, automatic number plate recognition for enforcement of rules, detection of violations, red light jumping, wrong lane driving, no helmet. All of you have experience if you drive, that you keep the helmet somewhere and you don't want to put it spoil your hairstyle. But then, when you see from far away, you will stop the vehicle and then try to put it. But there are real-time sensors, cameras all along the way to know who is doing this. Okay? So there is a lot of change. So the impact is there is reduced congestion, fuel consumption, obviously. The travel time is reduced with such kind of solutions. So this kind of what happens when you put cameras, right? How it does. So this is how it senses the vehicles. It creates some kind of bounding boxes. There are some algorithms that do this. Right? So they create this kind of bounding boxes and then keep counting in the lane 1 how many are there, lane 2 how many are there, lane 3, lane 4, and then which ones are the ones that are taking right, which are the ones that are taking left and so on. So obviously what happens is there is a better traffic management that you can do with this kind of internet traffic, sensing of this traffic. There are multiple types of sensors. Right? There are cameras and there are IoT devices also on top of it. So this is how an integrated intelligent traffic management system would possibly look like, where you have some vehicles going on the flyover, some vehicles on the roads, and at a crossroad, possibly they can be monitored. Something of much greater interest to the administrators or to the people in governance is something called as public safety and surveillance. Public safety is important. Right? So the governance, those who are in the government, they need to look at public safety. So what is being done? There is a command control room. Here also we have a command control room in Hyderabad. You all must be knowing that idea of command control room. So what they do is this kind of multiple cameras and multiple views from each of these cameras are getting projected into this kind of an environment. So what can be done? Those who are here checking up on their desktop system, any small movement that is happening. So for example, it could be about some important location where there are multiple crashes or multiple accidents that keep happening. To the people who are traveling, they cannot even, because we are at speed, we do not even know where the cameras are and we do not notice. But what has been done is, for public safety, a lot of surveillance has been added. You all know what happened in Mumbai earlier? That attack that happened in Mumbai. After that, every city, they have enforced, they have put a lot of this kind of cameras. And in fact, Usmania University, at our university, there is a building called as Usa building. There also there is a command control room. And from the data center, all the data gets, all the data goes and gets fed into the data center. From there again backups can be taken. So very interesting thing that happened is our students, they thought that they are in the hostel. Hostel they keep doing mischief. So what they did is at night they broke a camera. They hit with something and the camera broke. But they did not know that there is some other camera that captured that information also. So not only we could find that they are trying to do some mischief, but we could find who is the person, who are the people who are trying to break the camera also. Okay? So this kind of extreme surveillance, extreme capture of information is possible. Now if you translate this to what a city can do, obviously in a city there are many more important challenges. It is not you students just doing a little mischief. It could be lot more, many important things that can happen. The same thing happened in our district Nagar also. Okay. So, and also a little away from here, 40 main road there is a sweet shop, Gokul Ghat. That time probably the government didn't even think of computer vision. Now at important places there are cameras that can track. In fact, that is helping the government to such an extent that the government are able to identify that kind of challenging problems. They are able to sort out very quickly. Obviously, this kind of cameras across multi-directional cameras, moving cameras, there are various types of ways in which data can be captured. So you can see somewhere on the roads too, whenever it is dark, so many such cases that can happen. Something that was done recently what happened in Prayagraj, Kumbh Mela, right? So in Kumbh Mela, they have extensively used all these ideas of crowd and event management. You all heard of Kumbh Mela? So this kind of a congregation of people, it used to be such a big challenge for all governments. Because it's very difficult, right? In spite of doing all that, there was a little issue there. But it is very difficult to manage because in a group, when people are moving towards some temple, always there used to be some kind of stampede and people would push and so many such things because they want to go in a hurry and all that. But this time they have taken care to see that a lot of crowd and event management is done by using drones. Word of drones, right? Drones with cameras and aggregating all that information, multiple of these drones and those images being correlated. Right? What image is being fetched from one place, that is being correlated with the images being fetched from some other drone. So obviously what happens is they are able to come to certain conclusion as to where few people, not, it's able to pinpoint that one person in which direction he or she is moving. There are a lot of vendors also in such crowd. Vendors, they sell something. So there are such kind of places where these vendors are moving and causing trouble. Right? They are charging money and all that. So there is a lot of crowd management that can be done. To find out the density from all these cameras, there are again some specific algorithms which generate heat map. This kind of a diagram is called as heat map. Heat map shows the density of people. Then apart, there is a lot of urban infrastructure monitoring. Of course, this I think Hyderabad city has to adopt immediately on a large scale because if you are talking about detection of potholes, cracks and road damage, there is something each of us are getting affected. Then there are monitoring of bridges, flyovers, buildings, etc. And there is street fault detection. A lot of these are really capable of solving something that affects all of us as public. Right? So, and then progress of construction and encroachment detection. You all heard of Hydra, right? How are they able to get to know it? How do they get to know in the first place that there is encroachment in a site? Do they go around and find out from everybody? Or do people come and tell them something? They are using this advanced technique of computer vision, of cameras mounted on top of your drones. Because of that, what happens is they are able to very easily identify across multiple such kind of such flights that are being sent by these drones. This pothole information, there are a lot of algorithms again. I'm not getting into details of those algorithms. You can, those who are interested in doing some projects on this, will probably check out. So they are monitoring the, there are some more, without being politically getting involved in that. You see something like this, I am having facts related to our state. Collector, you have heard of collector? But what is that particular aspect where there is going to be a lot of impact? That aspect is called as environmental monitoring. If all of us, we are not only interested in talking about the roads or the buildings and public safety, but something that is going to affect the next generation also is called as environmental monitoring. So if we are not very careful about this illegal dumping, you can see how dirty it is, right? And illegal dumping that has been carried out across multiple cities, multiple places, that has been done for many, many years. So that makes the entire water getting polluted. You see a lot of places where there is a lot of discussion around keeping our ponds clean. And at some places actually ponds have disappeared because they keep dumping the trash all around, right? For many, many years. And then people kind of forget that there used to be a pond, there used to be a small lake or something like that. So this is to be stopped. So to do this environmental monitoring, use of your computer vision, all this is going to be very important. That apart, you see across the city also, we have seen number of times that after there is a fire, after there is a fire, then they start trying to check out if cameras were there, and then they try to find out if this from these camera feeds what actually happened. But in the meantime, what would have happened is the camera wires also got burned. Isn't it? The camera wires also could have got burnt if the building is catching fire. There is no way to detect. So these cameras that are there are special cameras which can capture the change in temperature. As soon as there is a change in temperature of this place, and if it crosses certain threshold, it is able to raise an alarm. And of course, there is something like for flood and for ensuring around the flood, around the park, and so how the changes are happening. Can see this. And there is something that I am really interested in, and it is really there is a great scope for doing real research or doing some kind of a real evaluation. And across the globe, there is a lot of interest. That is called as smart mobility, right? Smart transportation and mobility, where the passenger counting in buses and metros can be done, detection of unsafe driving behavior can be done. So many such kind of applications across. So what happens here is they are able to capture across the stations. So across various locations, all of the kind of cameras and mounted systems, camera mounted systems are available. So they would probably be able to integrate all the information. What is this? Okay. This is something. This is something like a shuttle service, autonomous shuttle bus. So those are driverless, yeah. Autonomous or driverless shuttle service. So this is something that IIT Hyderabad is also working on. And what also interests, like I said, if Narendra Modi is there on that kind of India AI summit, it's not only because he is the Prime Minister, but they are also looking at this healthcare and emergency response in smart cities. Not after there is a breakout, but even before that, right? Trying to find out. Apart from what happens for public safety, it is also like detecting the fall of a person. So it is fall detection that can help the elderly. I don't know if you have heard of that. It was very much in news that an elderly person, he was wearing a smartwatch, Apple Watch, and he fell, and that intimation, that notification went to his son, who was working in office at a very remote, far off place. At least immediately he could arrange for somebody to check out on his father, and then he could save. So fall detection. Person has fallen and that is getting detected in something like a smartwatch. So that kind of, at that level, there are algorithms, there is some work that is happening. I think all of you should be interested in doing something really serious on it. Similarly, in airports also that kind of a system is being installed. This kind of, can you even imagine that there could be automatic notification to your ambulances? Automatic notification to ambulances based on there is a fire somewhere, nobody needs to call. You already installed that kind of camera, and notification is directly going to the ambulance. Or in case of a fall of a person, can you also integrate this kind of notification being sent to your ambulance? So they come over and then things can be done much faster. So a lot of things need to be integrated. There is sensor input integration with your switches and alert broadcasting and sensing and commissioning. So all this can become something that is used in your governance and civic services. So governance and civic services, there are a lot of things that can also be done, like monitoring your waste and sanitation and illegal parking, public space cleanliness, automated complaint verification, and data-driven urban planning. All the urban planning that was there, was based on some kind of geographical survey. But it was not real time. There is something called as real time and something called as near real time. Real time is as and when it is happening, the notification is being sent, the information is being shared. That is how you can get a response. With all this as background, I think till now what we did was I just gave you some ideas as to how or what all can be done to make the city smart, right? And what actually can be, what are the various subsections that you can put together as a smart city. Beyond that, what real work is being done in all of this emerging advanced applications, you can get digital twins of cities using visual data. I don't know if you have heard, digital twin is just like a mirror. It's like a mirror copy. What all is really happening, I just get a copy of that. That is what is called as digital twin. There is a lot of integration in IoT sensors for multimodal intelligence. Multimodal means from your images, from your streaming data, also from your audio streaming, and also from your text data. These are all called multimodal. For example, if I get to know that there is, somebody can call me up and tell me that there is some kind of a severe traffic congestion at some place in Tamil. I can use that and try to correlate it with my camera feed and get to know how much of it is true. Right? So like this, multimodal intelligence and drone-based city surveillance and retail analytics in public market. This again becomes very important if you are trying to see, manage your public density based on which particular days there is heavy traffic and then and at which particular market area there is huge traffic, etc. So what is the core idea? What is it that these administrators or what is it that we really want? You want to bring in transforms in your city such that it becomes perceptive and adaptive. One example that I give you is in real time, your traffic lights, earlier they were having up to 90 seconds kind of a configuration. Now that got changed to 60 seconds or 30 seconds and so on based on real time traffic, time of day and so on. So how AI is different from your original rule based? Earlier also it was there, but it was rule based. Based on certain rule you would probably configure. But now it is sensing in real time, and then based on that there are certain changes, modifications getting happened. So very relevant to your topic as to how they relate to your sustainable development goals, SDG goals given by UN. So these AI-enabled cities are not only smart, but they are sustainable, resilient, and climate aligned. So I think you must be knowing that there are 17 goals that are given by UN, sustainability development goals. In which goals do our smart cities match up to? The SDG 11 matches up to is what is that is given as sustainable cities and communities. So what all that we have said about smart cities, smart mobility, safer public spaces, resilient infrastructure, all of this definitely maps to your sustainable cities and communities. Similarly, the SDG goal 9, industry innovation and infrastructure. AI-driven urban digital twin, cloud-native infrastructure, intelligent transport systems, all this map to this goal. Similarly, reduce congestion means lower emissions, environmental monitoring, energy efficient systems. These map to SDG 13, that is called as climate action. It is needed mapping to tell what kind of sustainability impact you find. One is intelligent traffic management mapped to this SDG 11 and SDG 13. You get reduced fuel and emissions. Similarly, environmental monitoring, we saw already those various bullet points and how it helps, right? So that maps to SDG 13, SDG 15. So impact would be pollution control and green power tracking. Smart governance and waste management to 11 and 12. Obviously, the main thing is efficient resource utilization, healthcare and emergency response maps to SDG 3. So that is faster life-saving interventions can be done. And infrastructure monitoring to SDG 9, long-term urban resilience. I don't have much time, but I will try to run through few more of the slides that I just prepared so that you get an idea as to how we can really use this idea of generative AI and AI for autonomous systems or autonomous vehicles. So one specific application that you can look at is how this application bring in transformations in autonomous vehicles. What actually happens in your real-time vehicles, or what is driverless cars or autonomous vehicles, how do they really start working? How it is possible that there is nobody and yet they are able to navigate through various locations and so on. I'm sure you must have heard of companies like Waymo. You heard of Waymo? So these companies, what they do is they have already there is a big fleet of vehicles which are running in the San Francisco and various other locations. As of now, they are not totally in India. A lot of companies, a lot of people are competing, right, to be in the Indian space as well, to build autonomous vehicles for Indian roads. Obviously, the enabling factor is all this data gets stored on the cloud, and in real time, there is some kind of a trigger, there is some kind of code because of which autonomous vehicles can work. So, because cloud offers this kind of massive processing power, what you can do on your mobile can you also do on what you can do on your laptop can be do on our mobile. To quite an extent, not everything, right? So similarly, what you can do on a server, you can't really do on your mobile because of the computational capability. But because of cloud, what has happened is huge computational capability across different data centers. That is actually what is being used rather than one particular system, one particular server or a few servers. What we could do without cloud was that I could actually go on buying more and more number of servers. Based on if my number of students have increased, I want to store a lot of data, I could go on buying more servers. But today nobody does that. You can store the entire information on cloud because it is scalable, because it is much cheaper, it is much faster, and so on. So these autonomous vehicles generate terabytes of data from various types of sensors, and that gets collected on cloud. So there could be various types of this kind of data that is getting generated. You have, if you put your vehicle on cruise control, what happens? That's why lot of data gets generated. When you put it on cruise control, it tries to sense in real time whether it is safe to move for the next few more meters, right? Or it will take some action. So like this, data is getting generated from various locations. One is to adapt, when you put it on adaptive cruise control, from your traffic signal, it recognizes what all is happening at traffic signal, it recognizes your surround view. You heard of surround sound? So that surround view is what is there in the current autonomous vehicles. Surround view, 360-degree view. Earlier, vehicles were only having cameras that could capture what is there at the back so that it helps in parking. Then they brought up new cameras at the front also. Now even the current vehicles in India have 360-degree cameras. Somebody crossing you on the left, right also you can see. Right? So if that kind of cameras are there, they are all sensing something. They are capturing that information. Right? So there are cameras which capture 2D and 3D cameras, or 3D images and videos. Radar is used which captures long wavelength radio waves to detect the objects. Radar does that, right? By using the signals. And LiDAR uses light detection and tracking, maps your surroundings with information. So what is observed is NVIDIA's Drive AGI solution delivers 320 trillion operations per second. 320 trillion operations. You can imagine the scale at which it is happening. So in real time, what is happening is all this data in-car processing for critical applications that goes to some kind of edge processors and then to cloud, and then there are multiple, there are multiple parts whose information is used, and then there is processing application. But the real challenge is we don't want to send all our data to cloud, wait for operations to be done there, and then get back some results. We are trying to do real time. Real time is not near real time. Not near real time, it is real time. Because if I want autonomous vehicles to do a brake, what will happen if I do it 5 seconds later? There could be a crash, right? So I cannot tolerate that. We cannot wait for that. So you want operators, whether it is brake or it is take left or take right or accelerate. Sometimes we need to accelerate so that you cross certain part and there is another vehicle coming and so on. Whatever action you need to take, it should be as fast as what we think of, what we do as a human would do. So that brings in this idea of edge computing. So this idea of edge is something that is far more useful or far more required than cloud. However, the huge computations cannot be done on edge. So there is a choice that is to be done. What part of your computation can you do on cloud? What part of your computation you can do on edge? And what part of your computation has to be done on device or on your car. Right? There are these days fast processors also available in your car that enable taking urgent or quick decisions, and a little later decisions are pushed to the edge. Those which can be processed a little later are pushed to the cloud. There could be automated data center on cloud, there could be network, there could be edge servers, and there are connected cars. So use of lot of IoT devices current IoT devices. Now it is all a connected set of cars, and there are regular networking applications, there are localized systems and algorithms and something called cybersecurity as well, and waiting to anything communication. So these are all called as connected devices, connected IoT. So there is integration of this 5G with IoT, with blockchain. All of this is done today to make your real-time autonomous vehicles run. So there are multiple layers. If you are even thinking of working on autonomous vehicles or drive, at least you should experience that, if at all possible. To see, there are AI chips and processors on top of which there are frameworks, edge frameworks, and there are so many such layers required. So if you go to implement, at least you should be knowing that there are sensors and vehicle control units, there is an edge AI module which connects to your 5G network tower, and then there is some kind of cloud infrastructure required to do this various operations at scale. The challenge is we are not talking about 10 operations or 20 operations, right? We are talking of huge number of operations at that scale which is required for a city. So that gives rise to this kind of a layered architecture. There are multiple devices, edge and cloud can be. However, there are various challenges which I think once you start doing, you will find that there are challenges and scope for you to do a lot of work. However, these challenges also bring in, if you want to scale, speed might get slowed. What is more important? Challenges with your data also, real-time scenarios versus data that is available. I think I'll stop here. There's a lot more to discuss, but I think this must have given you a broad idea as to how smart cities are really the thing that's going to come in by the time you people pass out. That means maybe in a year, in 2 years, it's not going to take long. Where the cities are all scaling up to become smart. So if cities are supposed to become smart, you all need to make it smart. They won't become smart, right? Students like you, those who are into science and engineering and so on, should start working towards that. So with this, I thank you all. for patient listening.
Thank you, ma'am. Thank you for that insightful lecture. And I'm sure all of you could relate to whatever ma'am was talking, because she spoke very clearly about how AI is related to various aspects of our day-to-day life. So I'm sure all of you must be using without knowledge, but now ma'am has related, ma'am has mapped the whole thing in front of you and shown you how beautifully AI is playing a role in our lives without our knowledge. Right? Thank you so much, ma'am. And I welcome all the dignitaries to join us in felicitating ma'am.
Can we have a big round?
So we have launched our Ideathon concept today, and this is to all the science faculty students that you have to keep in touch with your HODs and teachers, because we are going to plan monthly events on this Ideathon, which we will map with the Sustainable Development Goals. So once we plan, then we will circulate the idea to all of you. As Jam Madam is heading this. So in a short while, we will be starting with the valedictory section. We will just wait for our principal ma'am to join us. I request all the students to please settle down in your places. Your movement is causing a lot of disturbance to the program.
BSc second year genetics, raise your hand. BSc second year genetics. BSc second year genetics, raise your hand. Raise your hand. 1, 2, 3. 8 is the present attendance. So 9 people. Only you have a last BSc second year, you had done without raise your hand.
Madam.
Yes, ma'am. Please select now. Don't delete.
We will start with the valedictory session. For conduction of valedictory session, I invite Dr. Veeranari Rao, Head Department of Psychology. Thank you, Dr. Veeranari. I am Dr. Veeranari from Department of Psychology, and good afternoon, esteemed guests, respected dignitaries, and enthusiasts. Welcome to the function of National Science Day 2026 celebration with the theme Role of Women Scientists in Vikasit Bharat and Implementation of Sustainable Developmental Research and Innovation Program Cell in collaboration with Internal Quality Assurance Cell VCIU sponsored by and band. As you all know, since the day stands for promoting science's role in scientific tempo, promoting scientific tempo, innovation, awareness of science's role in national development through competition, seminar, exhibitions to inspire you. It is again, you only towards research and innovation. And since past 2 days, as the madam, convener and the director, Dr. Neela had beautifully given a description of what we have been doing since past, 2 days. This is the second day, right? So what were you doing? 3 days, of course, yesterday. What are the programs we have done? Competitions, exhibitions, and I think food science and nutrition and dietitian. I think you have come up with various different programs, right? And various other science departments also. And principal madam, in fact, remember the objectives of NSD, Sustainable Developmental Goals, and respected registrar madam introduced us with first, women achievers from various fields. So now we have come to the valedictory session.
So, in this note, let me introduce our beloved principal madam, ever energetic, humble and approachable principal madam on to the dais for this valedictory certificate with a round of applause. Well, you must be, kind of surprised what is she doing, since the science day, from social sciences, no, I stand for Department of Psychology and it starts with mind and brain, hello. Everything starts from, the thought perception. So I'm everywhere, psychology is everywhere, multidisciplinary. So I am for National Science Day. Do you agree, all of you? Yeah. Excellent. Now let me call upon Dr. Uday Saxena, Utopia Therapeutics, CSO and founder. With a big round of applause because he is our counselor. He is our counselor. Very big round of applause. That sounds great. And let me call upon Hemant K. Das, Chief Manager, South Indian Bank. Hello, sir. With a big round of applause again, our counselor. Yeah. In fact, sitting here today is because of our counselor, of course, by the tremendous energy, interest, and support given by our Honorable VC Madam, Registrar Madam, and Principal Madam. But other than that, these two as well, stands for this program. So another big round of applause. All the five. Oxford Research and IP Cell also. Come on, mandatory, So now comes the convener of the program, Director of Research and IP Cell, Dr. Y. Sunila Kumari, Continuing Director, R&IP Cell. Big round of applause, please. The prizes kosama. I know you people are waiting for that to wait. Okay. Now, let me invite Dr. Rupashree Mukhopadhyay, Organizing Secretary and Joint Director, R&IP Cell. Ever smiling, with so many activities. She's a researcher, she's a writer, she's a singer, or marketing. Please be seated. Well, now let me invite our principal madam to address the gathering here. In fact, since morning, madam has been addressing on so many points, but now please few words, madam.
Respected dignitaries on the dais, my dear colleagues from various departments and my dear students, good evening. So all of you have enjoyed the National Science Day. 2 days of celebrations we had. Yesterday you participated in various competitions, poster presentations, and were enjoying all the sessions. You have made some display. And today you have sessions by eminent speakers, and I hope all of you have interacted and gained a lot of knowledge on this occasion.